Okay, so now we are recording, I think. Okay, so can you see the slides now? You also have the slides in the Teams platform, so you can download the PDF if that's better for you. Right. So yeah, so in this seminar, I would like to present you all the bits and pieces of publishing, starting from. So what, Fatima? What are you? You are asking for the control. So maybe that was just a mistake. So first of all, why it's important to publish, and why it's important for you during your PhD to publish. Then we will talk about types of venues where you can publish, how is the review process, types of papers, right? Because not every paper is the same, there are different types of papers. We will also talk about ethics in publishing and also rankings. Not every venue is the same, and there are different rankings that you need to know to understand and to select the best venue for your work. Then in the part number 2, we will have a look at the literature part, I have called it. Basically, how do you organize an article, and some tips on writing. Probably when we finish the part number 2, we will make a break, half an hour break, a coffee break or a tea break, and then we will continue with the technical part. No, how do you actually write a paper? I advanced that no one uses Word to write papers, so everyone uses LaTeX. LaTeX is the norm. And that's why I asked you to install LaTeX in your computer. We will see other options to write using LaTeX, like Overleaf, that you may probably know is a cloud-based application where you can write collaboratively your paper. And then finally, in the part number 4, we will see the practical part. I will explain you this process that we are going to follow, the simulation of a conference, and I will explain you also about reviewing, about EasyChair, which is the web application we are going to use to emulate this conference. And EasyChair basically will take care of, you will be able to submit your papers into EasyChair, download the papers you need to review, produce reviews on EasyChair and so on. And that's very interesting because EasyChair is basically being used everywhere. So most conferences will use EasyChair, so it's good for you to know how this works. Okay, so let's start in the first part. So why do we need to publish? Why are scientific publications useful? Well, they are needed to communicate science, to make progress, right? If you don't publish about something you have invented, how do other researchers know about it? If you have invented, let's say, you have proven that P equals NP, you need to publish that for other researchers to know. If you make some advance, it's good that you publish it, because then other researchers can take your result and build on it. So publications are the way in which science makes progress. Right, but of course you need to publish it. I mean, it's not okay if you just publish your result in a website on a blog, but the scientific publications should be rigorous. It means that they are peer-reviewed. What does it mean, peer-reviewed? Basically, when you submit your article to a journal or to a conference, there is a committee that evaluates this work, and this committee is made by other researchers. So it's other researchers that take this paper, most of the time it's 3, 4, 5 reviewers, and then basically they read it very carefully, and then they decide whether this work is okay for publication, is correct or not. So it's very rigorous, and as I said, it's very different from just articles that you find on a blog or something like that, that typically don't have any value. If you are, for example, into theoretical computer science and you look for P equals NP, you will find a lot of web entries of many people claiming that they have solved this problem. For example, that doesn't have any value. Those posts have not been peer-reviewed at all. So it needs to be, to ensure that they are correct, they need to be reviewed. And also it's very different from other types of literature. The purpose here is not entertaining, but the purpose is to communicate a new tool or some technique that improves something. So the writing should be technical, should be effective, should be succinct and to the point. And also should be worthy. I mean, you need to, each paper should make a contribution. You need to have something to write a paper about. You need to have some novelty, something that has some progress in some part in some discipline. So it's a prerequisite to write a paper that you have something worthy to tell, right? And why is it important for you if you are pursuing a PhD? Well, because it shows evidence of the novelty in your PhD. I mean, it's important that you produce publications because publications are proxies for the work you are doing. No? If you are building a tool, if you are improving a method, if you are inventing a methodology, the fact that you have publications about it means that these results are interesting for the community, right? And because, well, publications are proxies, but they're an indicator of how good is your research. Many universities and departments, they have this prerequisite for a PhD defense. For example, in our department, we ask for 2 journal publications, right? So the PhD candidate should have 2 journal publications as first author to be able to defend the PhD. Other departments, other universities may have other regulations, but this is normally ensures a level, right? And they are important for you also because publications are a way to get involved with the community, right? You submit your work for review, then you get feedback by means of reviews. If you submit to a conference, then you can also go to the conference to present your work. You will get feedback. You will be able to discuss with other researchers, exchange ideas, and maybe some collaborations will pop up and ideas for improvement. So it's very interesting to go from time to time to conferences because it's where basically where ideas happen. And also, if you present something to a conference, maybe you build a tool, you publish this result, you go to the conference, you present this paper, then other researchers can build on your results. Maybe you make your tool available as open source, and then other researchers can build on that. That happens very often. No, in our group we have. For example, produce many tools as open source, and other researchers can take these tools and they have extended those or use those tools for other purposes. And in addition, you want to pursue an academic career, publishing is an essential skill. As I said before, is one of the main indicators for evaluating researchers is the publication record. So if you want to stay in academia, it's good that you have good writing skills. Okay, so where do you publish? You can publish in different venues. So for example, you can publish in journals which have specialized technical content. So in computer science, there are many journals, and typically they have a narrow focus. So for example, in our area, we have, for example, SOSI, which is software and system modeling, which is about modeling and model-driven engineering. You see, the focus is very narrow. There are other journals like IEEE Transactions and Software Engineering, which is basically about any topic in software engineering, right? But there are many journals, each one of them with a special focus. The thing about journals is that you can write typically papers as long as you want. I mean typically, because some journals they limit also the size. For example, IEEE transactions on software engineering, you are allowed to send papers of 15 pages, I believe, or 14. And if you submit the longer papers, then you need to pay a fee for each extra page. We will talk about fees and publication access in a moment. The idea is that you submit to journals whenever you have a finished work, which includes implementation, evaluation, and so on. And the publication typically takes at least 1 year or more. You also have magazines in which you have shorter papers, maybe 4 or 5 pages, with a more informal style, and typically for a broader audience, sometimes professionals, software engineer professionals, not only academics. And the top magazines in our area, I would say they are IEEE Software and Communications of the ACM. There are also books. You can write a monograph, and in some universities, when you finish your PhD, you produce the document with your PhD. Some universities, they send this for publication as a book with an ISBN, maybe by a local publisher of the university, and some other times by another publisher. There is also the possibility. Many of these books are actually collections of articles where a number of authors they write a chapter each of them. Maybe there is a book on some special topic, like for example model analysis, and then there will be a chapter written by a set of authors, but they are independent chapters. I would say that the top book publisher in our area would be Springer. So books, I find them, or book chapters are a little bit more not so common, I would say, right? Because they stem from seminars, like DAX tool seminars, but they are not as common as journal publications or conference publications. Again, conferences are also on a particular topic. For example, in our area, the main conference I think would be models, whose topic is everything related to modeling or model-driven engineering. And I would say that for the broader topic of software engineering, it's ICSE, International Conference on Software Engineering. So here, for conferences, papers are typically shorter, right? But they have also, they have a limited length, for example, 10 pages, including references or something like that. And the thing is that there is an acceptance rate. So here, conferences cannot accept every paper, but because conferences, they happen, let's say, in 3 days, there is a maximum number of slots. So for example, a conference may only be able to accept 30 papers, even if the conference receives 500 submissions. And we will see that the difference, a measure of quality of the conferences is the acceptance rate. So conferences with a very low acceptance rate, like ICSE, are considered very selective and of high quality. I mean, it's normal to submit to conferences, especially everyone submits to conferences, especially in software engineering and modeling. That's, I think, would be the main way of publishing. And also it has a quicker turnaround, right? Because you get an answer in a couple of months. Because you cannot spend 1 year reviewing those papers, because the conference has a date, and of course needs to accept the papers before that date. So another issue is that the conference registration is not free. So many journals, you can publish in those journals for free, but in a conference there is always a fee. You submit to a conference, but then registering to the conference is not free. And of course, if you submit a paper and the paper gets accepted, you need to register to the conference and you need to go there and present your paper, and that's not for free. Moreover, these papers will be published in so-called proceedings, which is something like a book with all the articles, and then accessing those proceedings is typically not free nowadays, right? So if I want to have a look at the proceedings of ICSI 98, they are not for free. So I need to have typically, and maybe my university has a registration and I can access, but typically are not for free. And nowadays, open access to science is more and more important, and there are a few conferences that are publishing the proceedings for free, like ETAPS. ETAPS is a good example. ETAPS is European Conference on Theory and Practice of Software. It's a very important federation of conferences, and they publish the proceedings with a Springer lecture notes, which are typically not free. But this conference basically uses the fees of the registration to pay the publisher for open access. So then everyone can access those papers for free, which is, I think, is a very good policy. And actually, the European Union, I think that they basically demand that the results of European projects should be open to the public. I think that's very good. And there are also workshops. Workshops are typically, they are co-located with conferences, affiliated with conferences, and on an even more specialized topic. For example, low-code development environment. This low-code workshop is a workshop which is affiliated with models, and the topics are basically on low-code environment. And the thing here is the workshops are, the papers don't need to be so finished and so mature, because the goal here is discussion. Typically, workshops are on a hot topic and on an emerging topic, and the goal here is more to have a discussion and to build a community around this topic. Right. By the way, you can interrupt me anytime. Probably the best thing is that if you use your mic, because otherwise I will not see your questions. I realize that I don't see here your hands. Okay, so I mentioned this briefly. How then you publish and how do you access? How people access those publications? Well, there are publications that are open access. One of them is called Diamond or Platinum, where the authors can publish for free. Readers can access those papers for free. I think that's the ideal option, but not many journals implement this scheme. In our area, I would like to mention JOT, the Journal of Object Technology, which follows this open access, Diamond open access. There is the other possibility, which is Gold open access, which is free for readers, but not free for authors. You see, this is a little bit strange. You submit a paper, you make a word, you submit a paper, and then you pay for the publisher to publish your paper, which is counterintuitive. But then the publisher makes these papers free for the readers. This has, I don't like so much this scheme because this gives rise to so-called predatory journals, which means they are just business. They charge the authors for publishing, but they don't have any quality assurance, right? Their reviews are very shallow, if any, and basically they make a business out of publishing these journals that they can be read by everyone. So there is something, you have to be careful here, and I will talk about predatory journals in a moment. But there are a few gold open access journals with more or less safe reputation like IEEE access, right? I'm also not quite happy with this journal at all, but it's a journal of IEEE that follows this scheme. And most journals, I would say nowadays, they follow a hybrid scheme, which means the authors can submit. It's free for the authors to submit and to publish the paper. But then those papers are not available for free to the readers. If the readers don't have an institutional subscription, they cannot read those papers. But you as an author can pay a fee, which means that if you pay that fee, your article will be open access. And even if other papers in this journal are not open access, the readers can read your paper in an open access way. Until a few years ago, most journals were closed, which means they were free for authors and paying for readers. But nowadays, I think most of the journals, they follow a hybrid scheme, which means they are still closed, but if the authors pay, they can get the paper open access. And of course, there is the green access. What does it mean, green access? Some publishers allow authors to put their papers on a repository like archive. I don't know if you know this. This is, I will click on here. Let me check. I can do archive. Yeah, that's a repository that is run by Cornell University, where you can find ordered by topic, physics, mathematics, computer science, many preprints. What is a preprint? A preprint is a version of your article before the final format editing, right? It's the version of the author that you can put there. You can put it there into, I think, into time frames. Before reviewing, so you write your paper, you put it in archive, you send it to review. That's very normal. That's not what we do in our group. The other possibility is you send the paper to review, the paper is accepted, and then you publish the paper in this repository. Why? To provide open access to everyone to read your paper. I would say in our group, we always do that. We don't use archive, but we use the website of our group, and also in our university there is a department that is constantly looking at your publications, and they will put an author copy of this publication in a repository of our university. That's very nice.
I have a question.
Yes, please.
I was like wondering if somehow there is like a limitation, because like now you say that you can send to publish and then like accept it in the journal, and at the same time I can just publish like in like by myself in a repository. So I was like wondering if there was like a certain point of something that I cannot do after I send it to publish. Like, because if I send it to publish to a journal and then it's for pay there, and I put it for free, I don't know if like there will be an issue there, like legally.
Yeah, of course, there is an issue. That's why I say some publishers allow authors self-archive. For example, there is what is called an embargo period. For example, I don't remember exactly. I think it's Springer journals. They allow you to post your paper on your website only after 1 year after publication, right? So they profit from this 1 year. From this 1 year, readers should access the publication in the journal, and then afterwards you can publish, you can post the paper on your website. Some journals have this embargo procedure.
One last question, and then like for this information, we know like in the moment we're publishing with like the specific paper type, or just like the full, like let's say the full magazine or conference, or like they have like a rule for all the papers they're coming. So like we don't have to ask specifically to the moment, or just we just need to pay attention to the type of like journal we are sending to publish?
Yeah, of course. You need to decide. It's the author who decides where do you submit your work, either if it is a journal, a magazine, or so on. Sometimes you see the publisher has a number of journals that are related. Right? The Springer has a few journals about software engineering and so on. So sometimes you submit to a journal and then the editors realize, okay, this paper would fit better in this other journal. And then they ask the authors, would you like to transfer your paper to this other journal? But that's very seldomly done. So it's usually a decision of the authors. Did I answer the question?
Yes, thank you.
Okay. Any other question? Right. Yeah. So let's see how is this process. So first, how do you publish a paper? So first of all, the first requirement is that you have something to publish. I mean, that's the main point. So if you don't have anything to publish, you cannot write a paper. I mean, you can write a paper, but it will never be published. I mean, this sounds silly, but that's the main point. And work that is worth publishing, it means it improves something relevant. It improves the state of the art in your domain. It's relevant, it's significant, it's original, it's evaluated, and it's proven that it will help someone to do something, right? Then you need to choose an appropriate venue. So, for example, a workshop for something which is incipient and is not nothing, and maybe it's just a little bit more than an idea. You can submit to a workshop to receive feedback and to discuss. You could select a conference if your work is a little bit more mature, and most importantly, if you have some implementation and some evaluation. I'm talking about implementation because that's the kind of work that we do in software engineering, right? We implement things in tools, and tools are running. So normally you will have implementations, right? And for many conferences, it's not enough to have an implementation to say, okay, I have this thing working, but you need to have some evaluation. So some evidence, some experiment that shows that your work improves something, right? That is better than other tools or improves a process, makes people more efficient. And for journals, you would submit to a journal when you have something that is really finished. It's finished, including an extensive evaluation, right? For conferences, you can have an evaluation which is short or which is preliminary, but for journals, typically you need to have a carefully designed evaluation. Then you select the venue, you write the paper. You need to check what is the format, what are the page limits, and write the paper. And the paper, as I said, is a proxy, no, for your work, right? The important thing, of course, is the work, but you need to write a paper. And your work is going to be evaluated on the basis of the paper. So the paper should be carefully written. When I said carefully, it's very carefully, because that's how your work is going to be evaluated. So you can have, you may have built a very spectacular tool or implemented something great, but if your paper is crap, so to say, you will get a reject. So focus on the paper, because that's how your research is going to be evaluated. So don't expect to write a paper in one afternoon. That's completely silly. Not even 1 week. That's not possible. At least in a group, that never happened. So the minimum amount of time, I would say, is 3 to 4 weeks for a conference paper. For a journal paper, it can take much longer. And also, don't write the paper and say, I have done this. I have implemented this too. So what? Who cares that you have done that? You should position your work with respect to related research. What other people have done is this. I have done this to improve the state of the art. But also you need to motivate your work. Why do we need the tool that you have built, for example? How does this tool improve? So you need to motivate that your work is relevant and you need to position your work with related research. You need to implement and evaluate your work. Then you submit your paper, and you are still not done, because, as we have seen, papers are peer-reviewed, right? So it will be evaluated by, most of the time, I would say 100%, by anonymous reviewers. What does it mean? Well, it means they are other researchers, but you don't know who they are. I think that's the most fair scheme, because if you know who they are, maybe they will be afraid to criticize your work. So that's I think, a standard today, that reviewers are anonymous. So you don't know who is reviewing your work. Even if you see in conferences that they have a program committee made of 20 people, you will receive 3 reviews. So you don't know who of these 20 people have made your 3 reviews. And then the reviewing means that the reviewers will read the paper, will write reviews, and will suggest changes, and will suggest whether the paper is acceptable or not. So now the notification, I mean, the decision depends. No? If you are submitting to a conference has a deadline, and it needs to accept the paper before the deadline, right? So typically you have an accept or a reject. It's a binary decision, right? But for journals, there is an iteration. That's why the process for journals, I would say, is nicer, right? Because you have an opportunity to reply to the reviewers. So maybe a reviewer say, okay, I think this is wrong, this theorem is wrong, I think this proof has a flaw. You have the opportunity to reply and say, look, no, this is correct, and so on. And you have the opportunity to improve your paper, right? For a conference, you also have the opportunity to improve, but this is just one opportunity. If you get an accept, you still have the opportunity to, we are here in paper revision, to improve the paper, taking into account the reviewer's comment. That you only have, you always have to do. So you have to take the reviewer's comments and try to improve your paper. But for conference, this is a binary decision. Sometimes on conference, they have a rebuttal process in which the authors can reply. The authors can reply, but they cannot modify the paper. They can reply to the reviewers, and there will be a final notification after taking into consideration these rebuttals. So if you don't get a reject, then you have the possibility to revise your paper, right? So you improve the paper, and typically for journals, you will need to prepare a letter explaining how you address the reviewer's comments. So you typically say, okay, I have changed the paper in this way to address this comment, and so on. And then for journals, let's say you get a major review, then you will submit again the paper with the changes together with this letter, and then they will be sent again to the reviewers, and the loop starts again. So you see that for a journal publication, this can take typically 1 year, if not more. And okay, then at some point, maybe the paper will get accepted. So that's not the end of the story, because then the paper needs to be published physically, right? Maybe not on paper, but maybe on the web, electronically, but it needs to be conformant to the style of the journal and so on. And then you typically need to submit the sources, typically LaTeX files. Then there will be people editing your sources and putting your paper in the final format. Then they will send you what they are called the proofs of the paper, and then you will need to revise whether there is some error or not. And then that's the end of the story. Any questions so far? Okay. Right. So reviewing. I have mentioned that reviewing is what is called single blind, because the reviewers in this scheme, they know who the authors are because the author names are on the paper, but the authors do not know who are the reviewers. So the reviewers have freedom to criticize as they want, but criticize, I will talk about ethics of reviewing in afterwards. because of course you need to do ethical review, and you cannot criticize this for criticizing, but you need to help the authors to improve the paper. That's the point. So it's single blind because even if you see that there is a program committee of 20, 30 reviewers, you don't know exactly which one of them has reviewed your papers. There is also double blind, and this is nowadays, I think this is more and more common for conferences. I think double blind is only implemented in conferences nowadays, and it means that authors are also anonymous. So you submit your paper, but in your paper you don't put the author names, you put anonymous, and you refer to your previous work in the third person. Why is that? Well, because that tries to avoid a bias, right? If I am a reviewer and I see a paper, let's say of Lisette, because I know that Lisette is a great researcher with a great reputation, maybe my bias is to accept the paper because I know that Lisette writes very good papers. That's bias. Maybe it's not a conscious bias, but this bias can exist. Or maybe I see, okay, this paper is from Harvard University or from MIT. So I think, okay, this should be good. So maybe the reviewers will have this bias. If I see a paper by Juan de Lara, wow, this is a crack researcher, this is going to be bad for sure. Making authors anonymous tries to avoid this bias, but introduce a lot of complications as well. There is also the possibility that everything is open. So authors are known, reviewers are known. I have never participated in a conference or journal with this open policy, but in some disciplines that's also possible.
Excuse me.
Yes.
Excuse me. In the double-blind type, if there were some references to the previous works, is it written anonymous in the references or not? How we can manage that?
Yeah, that's a very good question. If let's say you have a publication where you describe a tool, and then you want to extend, you have extended the tool and you write another publication. That is anonymous. How do you refer to that other work? You have to refer in the third person. So you have to say, I took this tool, but the reviewer will not know if the tool was created initially by you or by some other people. So you have to take everything that you built upon for this new paper, you need to refer it in the third person, saying, I took this work and I extended like this. Of course, it's very likely that this previous work is also yours. But that's the way to go. And also, there's an issue. If you want to publish additional data, for example, if you want to make your tool available, you will put it in GitHub, for example. But if you make this GitHub repository available, then people can look into the GitHub account and discover who you are. So there are a lot of issues for double blind. The idea is not to make impossible to know who are authors, but the idea is to try to eliminate bias. And I think that's fair, right? Because I think independent from the institution, from MIT, the Universidad Autónoma, I think everyone should have at the beginning the same chances and not to have a bias in the reviewers.
Thank you.
More questions? Yeah, for example, models starting from 2 years ago is using a double blind policy. ICSI as well. So I think most top conferences are using double blind. For journals, it would be more difficult, right? Because you really need to. I mean, there are longer papers, more deep papers, so probably that would be more difficult. Okay, so if you submit to a conference or to a journal, how is your paper going to be evaluated? So I took from here the evaluation criteria from ICSI because I think they are very nicely written. So typically your paper will be evaluated on soundness, whether you apply in a rigorous way research methods, significance, whether you make an important contribution with respect to some software engineering challenge, and novelty, whether whether you advance the state of the art, but also look at this verifiability. Whether you claim something, you support this claim by an experiment, some evaluation, whether other people can replicate this evaluation. I think that's very important. No? If you claim that your tool is twice as fast as this other tool, please put data on somewhere that people can replicate. That's super important in other areas like, if I develop a vaccine or something like that, and I claim that this vaccine works this way, then this should be, other researchers should be able to verify my claims. And of course, the presentation, the writing itself. So you need to have a writing style that is typically is English. So the most conference you will submit will be English. So in Spain, of course, we sometimes publish in Spanish conferences. But for your PhD, you will submit probably to international conferences, and the language will be English, and you should be able to write well in English so that the reader can understand what you are talking about. Okay, I would like to mention ethics as an author, or rules that the community follows. For example, you cannot submit the same paper twice to several conferences. So you cannot submit, you write a paper and you submit to several conferences and then see if some of these conferences accepts the paper. That's not allowed, and that's a very bad practice. Don't do that ever. Because every paper should contain a substantial improvement to previous publications. You need to have proper citations to your previous work and proper explanation of how you have improved that work. Submitting your work to several venues is called plagiarism and is a serious offense in the academia. If you do that, probably you will be out of academia. But it's normal to extend, if you write a conference paper, it's very normal that then you make some improvement, probably maybe extend the tool, extend experiments, and then submit to a journal an extended version. That's very normal. Typically, if you have like a 30% of increment, that's fine. And also many times the conferences, they organize special issues in journals. So they invite the best papers for extended versions in the journal. Also, at the end of during your career, you will write many papers, right? So it's not allowed to take phrases or paragraphs from your previous papers. That is called self-plagiarism, right? Remember, when you write a paper, when the paper is published, you depends on the open access policy. You do not have the copyright anymore. But typically, this copyright is transferred to the publisher. So you don't own. You are not allowed to take these literal phrases or literal paragraphs, right? So you need to add proper citation, and also even for images, you write an image, you create an image maybe of your tool architecture. You cannot use it twice into different papers unless you properly cite the previous paper. Of course, you will make experiments, maybe measuring times or doing some other types of efficiency measures. You are not allowed to fabricate experimental results. That's a crime directly. And you have seen in the newspaper many researchers in the biological science fabricating results or from physics, and there are criminal charges for that, because that's basically, that may have very far-reaching consequences, right? If you fabricate results about vaccines or about medicines or drugs, and if they are not true, that's a problem of public health. And also another thing, and this also depends on the research group. If you see papers with a very long list of authors, that sometimes it smells very bad. That that means who is the author, right? So every author in that list should have made a contribution to the paper, ideas, implementations, experiments, writing. So if you see very long list of authors in computer science, that's a very bad sign. That means that everyone in the research group is participating in every paper. That's not possible. I mean, not everyone is working on everything. That's just because remember, researchers are evaluated based on publications. That's just a way to improve your publication record. That, I mean, it doesn't make sense, right? And we will also mention something about the order of authors later. Of course, in other disciplines like physics, it's common to have very long list of authors. For example, if you have read these papers about this collider of particles, so whenever there is the Hadron Collider, so whenever there is a paper about that, maybe there is 100 authors. Why? Because these experiments are huge. There are many people involved in those experiments about particle physics, and therefore there are many authors. But not really in computer science. Computer science is not very common, except in some particular cases.
Excuse me, can I ask a question? If we get some consultation during our research from another professor from our research group who is not the supervisor of the thesis, but maybe another professor, and just get some guidelines or consultation, not any implementation, or I don't know, any specific contribution. In that case, should we put the name? Is it ethical to put the name in the name of authors because of two or three times of consultation, or not?
Well, there's a fuzzy line between what is an author and what is not, of course. If there is, in my view, if you have just asked a few questions for guidance, maybe it's not enough for considering him or her an author. I believe each author should participate at the end in the writing, should have read the paper, provide also comments on the paper, and agree that this paper will be submitted to that conference, right? If you have asked him or her for guidance, it would be a good if your paper gets accepted, it would be very good to mention him or her in the acknowledgement. Typically, there will be a final section on acknowledgements where you say, okay, this work was possible because of the European Union, blah, blah, blah. You know this phrase that we need to put in publication, but also you can acknowledge the viewers for the comments that they provide you, and also to these other people that help you prepare.
Thank you.
More questions?
No, thank you.
Okay. Yeah. So and then you publish, and where do you find those papers? So typically in publisher databases. So IEEE Explorer, ACM Digital Library, Elsevier Scopus, Springer Link, and so on. Most of them, they require a subscription. If your institution has a subscription, you will be allowed to access those papers for free if you are in the university or you are using VPN. You can also use community databases. For example, in computer science, probably you all know DBLP database is a database of papers where you can find papers ordered by authors. You see here, DBLP has even papers written by Alan Turing, even in 2012, right? That's strange. And basically, it's this author here, Bailey, that wrote a technical description of something that Alan Turing wrote. And for some reason, he added Alan Turing as the first author. I think this is not ethical at all, but he did it. And you can find also databases. There are many other community databases and databases built by companies. For example, ResearchGate, maybe you know it, is something like a social network where authors can publish their papers, can post their papers, preprints typically. ResearchGate is also, you can find many papers there. And there is, do you know CHAP? Have you heard about this? CHAP?
Yes.
Yeah.
Yes.
That's
Yes.
yeah. That's not. I think it's not legal because it's a way to provide access to papers that are beyond paywalls, right? But it's very handy. I mean, now with this COVID confinement, I would need to use VPN to access my university IP addresses to be able to access these libraries. But with a CHAP, you can do it more easily. No? So it's probably not legal, but it's very handy. And I think it makes science open. And I think that's a good goal. Right. More things. Where do you publish? Now we have talked about journals, conference, and so on, but you also need to consider not only the type of venue, but the ranking, right? So not every journal or conference has the same quality. So there are rankings, and I would say that one of the most used one is the core conference ranking. So where you see that there is a number of rankings. So there is A-star conferences. So this is a ranking for conferences, right? So only 4% of all conferences are in this rank. There is A conferences, B and C conferences. So typically, A-star conferences are extremely selective. For example, if we look at ICSI, I would like to search by acronym. Okay, right. So I have ICSI here, which is A-star. And so you see that yeah, there are also comments. So A-star conferences are super good conferences. So you have, for example, models, which are A conference. A conference are very good conference, probably the top conferences in your areas. There are also B conferences, like I would say SLE, Software Language Engineering, which is also very relevant in your area, which is a B conference, right? So there are these ratings, and they give you an idea of the quality. How is this quality measured? Basically based on acceptance rates, how selective is the conference, based on if very good researchers publish in that conference, if the top researchers in that community publish in those conferences, and other criteria. So I would say that A-star are extremely good, so only submit there if you have a super good paper with super good evaluation, which is very well written. A conferences, I think that's submit to models whenever you have an interesting result in your area, but also B conferences are very good. For example, in our area, I would say FACE, Fundamental Approaches to Software Engineering, or SLE are good conferences. And there are other conferences that have no rating. For example, ECMFA, European Conference, on Modeling, Foundation, and Application is a good conference, and it doesn't have a ranking. There are other rankings, maybe your country, for example, in Spain, we use other rankings, but I think the core ranking is the most well-known. For journals, there is the most important ranking is called Journal Citation Report. And basically, it measures the impact of each journal based on how many citations each paper published receives. So if a paper receives many citations from other paper, it means it's an important paper. So if this journal publishes important papers, this journal is important. I think that the journal with a higher impact factor is Nature. Nature publishes, it has different journals, but typically publish very high impact research, typically related to physics or to bioscience. So it's not somewhere that it's not a journal where you will publish something about software engineering. So in our area, I think the highest impact journals are IEEE Transaction on Software Engineering. I think this is the top journal in our area, but also recently Empirical Software Engineering Journal. There are also ACN transaction or software engineering and methodology, then software and system modeling, IEEE software, which is a magazine, information and software technology, and journal of systems and software. And this this impact factor is just a number, right? It's just a number, 2.5, 1.3. But the journals are classified in quartiles, right? So you take all the journals in a given domain, software engineering, you classify, you order those journals by impact factor, and then you break this list in quartiles. So Q1 are typically very good journals. So typically in software engineering, we have, I would say, all these are in the Q1 quartile. Q2 are also good journals. So typically when you submit your curriculum for evaluation to your institution, for example, they will mostly look at Q1 and Q2 journals. And regarding conference, they will look at A Start and A conferences. So try always to publish in the best venues in your area. Questions so far? Okay, and of course, everything nowadays is a business. So there are people that make a business out of publications. So once you publish papers, you will receive a lot of spam about unknown journals and unknown conferences asking you to publish in that journal and asking you to be a reviewer for that journal and asking you to publish in a conference. Why? Because they have this gold open access scheme where the authors pay for publication. So that's their business. So this is just an example of something I received a few days ago. They have crawlers that basically try to go through papers published in other journals, and they try to get the names and the email addresses of the authors, and then you will receive spam about this. Never publish in those journals. So please, before selecting a venue, ask your supervisor. And of course, have a look at the journal, citation reports, or at this core conference ranking. Always know where you are publishing, because if you publish something here, is something which is bad for you. If people will see this publication in your curriculum, will say, okay, I mean, no, I mean, this is not a publication. This is just something else, right? Because most of these journals, they don't even have a proper reviewing process. They will say, well, here they say rapid publication 90 days, but I have seen rapid publication 1 week. I mean, that's just a joke. There is no proper evaluation of the quality. So never do that. More rankings. So not only publications and venues, they have a ranking, but also authors. How do you measure authors? So I have said that your curriculum will be evaluated also based on the projects and the tools you have made open source and so on. But a very important factor is the publications. And nowadays, basically, when you have to, let's say, review 20 curriculums, one way to do it is just count the publication. But of course, quantity is not equal to quality, right? And another metric that you normally see is the number of citations. If you publish a paper that receives many citations, it means that your paper is relevant, because it has been used by many other researchers. And of course, this also depends on the area, because if you work in machine learning or artificial intelligence, they publish like math. They publish a lot of papers there. Shorter papers just with a variation of parameters. I may be a little bit biased here, but in these areas there is a much more papers being published. So therefore, the citations are typically higher. So one metric that you will maybe heard about is the H index. What is this H index? So if you have an H index of X, if you have X papers which are cited at least X time. For example, you have an H index of 30. If you have 30 papers that have been cited each, at least 30 times. So that's a very well-known metric. Where can you look on these metrics? So, for example, you can go to Google Scholar. You probably know about it. It's a repository with papers, but they also provide this kind of metrics. So I have taken Lionel as an example, and you see it has here 29,000 citations. That's really a lot for software engineering. H-index 80, which means he has 80 papers which are cited at least 80 times. And you see, for example, this paper here, a validation of object-oriented design metrics, has been cited more than 2,000 times, right? Okay, so where you can investigate about these metrics, Google Scholar, you can have a look also at DBLP, you will also find publication there. You can also look at Scopus, where you will find publications, citations, and H-indexes. The Web of Science is the place where you will find the impact factor for journals, but take into account that this is not for free. So you need a subscription to access the impact factor of the journals. But if you go to the journal website, you will probably see the impact factor of that journal. There are also, for example, other sites like Microsoft Academic, which is a very nice website where you have a classification also of rankings of authors, of publications, and so on. And there are other websites like Semantic Scholar, ResearchGate, where you can also see these rankings. Right. So questions so far? Okay, so let's conclude with types of papers. When you write a paper, there are different styles of papers. For example, one type of paper is a systematic mapping study. I don't know if you have heard about this. It's basically a paper that summarizes a state of the art in a certain narrow topic, right? For example, an analysis of the literature on modeling using mobile devices, for example. That would be a valid topic. So what's the goal of this paper, of this kind of papers? So it's understanding what is the state of the art. So you provide a curated list of papers that are interesting, you provide a summary, and you provide some conclusions. It's also useful to see the frequencies of publications over time. So if you see that this topic is increasing in popularity, you will see that the number of papers increase over time. And it's very useful for people trying to get into some area, for newcomers. But it requires quite a lot of effort. So that's typically the steps that you will follow to write this paper. So you first of all want to answer a research question. Then you conduct the research, where you will find for the papers using some query on a main database. You will screen those papers to select only the relevant papers. You will classify those papers basically based on keywords or even building a feature model, and then you will extract the information from there, and then you will write the paper. It takes a long time. It takes a long time because also you need to read and to consider many papers. If you do this mapping study, you can basically publish everywhere. I think every journal can accept this kind of papers, including SOSIN, Information and Software Technology, and so on. There is one journal that is basically only publishes systematic mapping studies, which is ACN Computing Surveys, which has a very high impact factor, but is extremely selective and it's very hard to publish there. You will even get, instead of normally you will get three reviews, here you will get probably 5 or 6 reviews, so it typically takes a lot of time. Okay, the most common type of paper is just a research paper that describes some research that you have done. That should also compare with related research, but not to the detail of a systematic mapping study. And even within research papers, you will have, typically in a conference, you will have long or full papers, which is basically complete research. including evaluation. This will typically be 10 pages long, maybe, or 15 or something like that. But you will probably also have short papers in a conference where you have papers describing new ideas, even work in progress. Some conferences accept short papers, and workshops, for sure, they accept short papers. The Lowcomote workshop that we organize accepts both long papers and short papers. This is just an example of a typical paper, which is a research paper. Right. More types of papers. Experience reports. Experience reports, they are basically many times connected to research in industry. So for those of you that are now doing your research in industry, these kind of papers might be interesting because they typically describe the challenges that are faced, the approaches taken when you apply a given technique to a real problem. For example, you invent a technique based on model-driven engineering and you apply it on your company. That's very good because you will be able then to write an experience report. So how was this process once you apply this technique? There are many conferences that they offer an industrial track. For example, the practice and innovation track at Models, or in ICSE, there is software engineering in practice, I believe. So these kind of experience reports are also very valuable because they put research into the practice of a company. What else? Most papers, they will have some kind of evaluation at the end, but there are some papers whose only purpose is to showcase or to provide an empirical evaluation. So these are papers with just empirical evaluation. Many times they involve a user study. For example, you want to test whether a tool is better than another to perform some activity. For example, we recently in our group we created this, we wrote this paper describing an empirical study, which was basically comparing a Socio, which is a tool that we have built, which is a chatbot for modeling, where you describe requirements, and then these requirements are parsed and transformed into a diagram. And we wanted to compare the efficiency of doing this with respect to the efficiency of collaborative modeling in a traditional setting. Using, in this case, it was Creately, which is a tool, a cloud-based tool where you can collaboratively create class diagrams. So we wanted to basically check which one of the tools was more efficient to do collaborative modeling. So of course you can submit this kind of papers to any venue, but there are venues that are specific to this kind of papers. For example, the Empirical Software Engineering Journal, they basically accept papers describing empirical evaluation. There are conferences on empirical evaluation like SM or EAS. More things, tool demos. You can write a paper that basically is a short paper that describes a tool. And the purpose of this tool, of this paper, is basically, these are papers which are submitted to conferences, and the idea is that you will make a demo in the conference. So you will not do a normal presentation, but you will do a demo, a live demo. So typically, many conferences, they offer tracks where it's a tool demo track where they accept this kind of tool demo papers. And I think these kind of papers are very relevant in our community because we always make tools, and it's interesting for other researchers to see these tools in action. And finally, posters. Posters are shorter papers that are not really, they are submitted to conferences, but they are not presented with a slot. And they are not presented with a talk. But these posters, basically, they are posters. So I mean, they are physically printed, and then you put the poster into a wall, and there will be a session where other researchers can go there, read the posters, and ask questions to the authors. So the authors should be physically close to the poster. And typically this happens during coffee breaks. And it's also quite interesting. I mean, it's fun. You will go with your when the conference were physically held, you took your coffee with your cookies, and then you go to see these posters and talk with the authors. So it's very interesting because it gives you a very very lively feedback about your work. Okay, so I will finish this section, and I think we will make a break now with a few tips. The first one, I mean, these are general tips. The first one is be prepared for rejections. So if you cannot cope with rejections, you will have a very hard time in this PhD and in your academic career. So failure is part of the process, but you need to learn from failure. I mean, and failure is interesting in the sense that failure means you will get your paper rejected, but in any case, you will have reviews. You have to learn from these reviews. You have to read the reviews very carefully to put you in the mind of the reviewer and try to modify, try to improve your work, improve your paper, taking into account this reviewer comment. If you cannot cope with rejection, I would suggest you to drop the PhD right now, because it will only cause you pain and suffering. And I mean, failure is normal. Everyone has rejected papers. I have had many papers rejected, but you need to live with it and make out the best of this opportunity for improvement. If all your papers are accepted, you will not learn anything, right? So it's only from failure when you learn. Second thing is take ownership of your work. So do not expect that your supervisor will write the paper for you. This is your work, and writing, communicating your work is part of the PhD process. Your supervisor will help you a lot, writing and polishing the paper and giving you advice, and will help you a lot with writing. But do not expect that the supervisor should take the lead in writing a paper. This is your work, and this is part of your PhD. Good research needs good writing. So good writing skills are almost as valuable as good researcher skills, because at the end of the day, you need to communicate your result. And everything takes a lot of effort. If you don't put effort, you will not accomplish anything. Inspiration exists, but it has to find you working. I mean, if you don't work, you can have nice ideas. Ideas need to be realized, and ideas need to be finished. If you are not the kind of person that finishes things, you will not finish your PhD, right? So a PhD is for people that has good ideas, but then put them into practice, implement them, and finish them. And finishing here is very important. And a good paper requires a lot of work. Right? It's not only the research that takes a lot of work, but writing a paper requires a lot of work. Okay, so I'm taking much more time than I expected, so I would suggest to take a break here, and then we can continue at, I would say, 11, and then we will go quicker through part 2, 3, and 4. Is it okay for you?
Yes, thank you.
Yes, thank you.
Yes.
Let's finish here. Do you have questions about this part?
Yes, Juan, I have two questions.
Yes.
Okay, my question is about the tool demos, which you are talking about the types of paper. So in the type of paper, when we have to write the paper about the tool demos, in that paper we just have to describe how the tool is going to be work, or the actual implementation of that tool.
Yes, well, I will talk about the structure of papers later, but here you focus on the tool, right? Why is the tool interesting? Why is the tool useful? You describe typical use cases for using the tool, so you describe how the tool is used, but you also describe the architecture. I have used CMF, I have used whatever, you saw maybe an architecture diagram and things like that. But the idea then is to make a tool demo. I think that's the main factor, a demonstration, a live demonstration during the conference. And sometimes for evaluating these kind of papers, the conference required a video showcasing the tool. So you see, if you see here, we have here a link to YouTube where we have placed this demo that the reviewers can use to see how is the tool working.
Okay. My second question is about the poster papers, in which in the poster paper we just have to define some new idea, or we can just also write something systematic review or about any evaluation or something.
Well, posters would not fit with a systematic review, so they are typically for very initial ideas. So where you may have even a very light implementation, a very light prototype, but typically poster papers, this is the poster. But there is a paper. Yes. There is a paper with it, probably maybe it's 2 or 3 pages long. Very short papers that describe very initial ideas. This is also quite often used for PhD papers, and maybe you have heard about this SRC competition that you may have received a mail from Davide Di Ruccio. The SRC competition is a competition that is run through different ACM conferences, and the students need to write a paper, a very short paper, and they need to prepare a poster. And then there will be a kind of evaluation of the work by some reviewers, and there will be a couple of winners. So this is typically. There are many conferences, they have these poster sessions, which is a way to enforce, the collaboration and getting feedback. So it's very interesting. I have sometimes submitted posters to some conferences of very initial works that I wanted to have a feedback.
Okay, thank you.
Okay, more questions?
Hi, this is Felicien.
Yes.
I would like just to ask you about the ordering of authors in a paper. Does it matter? Or
about the what?
The ordering of authors.
Yes. We will talk about this later.
Okay.
Yes. But yes, of course, it matters. So I can mention it now. Position is important. So typically, the first author is the author that has done most of the contributions, right? So that's the normal rule. For example, in our department, the PhD students are required to have 2 journal publications as first authors, because that shows that they are the main work being done is from the PhD. But there are also other rules, and sometimes you even say explicitly mention those rules, you follow them. For example, alphabetical order. In some research groups, they order the authors in alphabetical order. But if you do that, I would recommend to put an asterisk in the paper and say, all authors are ordered alphabetically, just to avoid any possible problem. So typically in your, I think that in most groups in computer science, we follow this positioning, right? Not the alphabetical order, but if you follow alphabetical order, I think it would be a good idea to explicitly mention that to avoid problems. And as I said before, each author in the author list should have a contribution in the work, either ideas, implementation, evaluation, writing, and everyone, when you submit a paper, all the authors should be aware of that the paper is being submitted. All the authors should have read the paper and agree with that to avoid any problem. Did I answer your question?
Yes, please. Yes.
Okay. More questions? Okay, so I will close this call now, and I will start a new call at 11. So we can use this time to, as you see, take a coffee or whatever. Okay, so see you in 20 minutes.
See you. Thank you.
Perfect. Okay, so right now we have talked about the context of publishing and why publishing, where, and the process, and so on. But let's talk about what are the main parts of a paper and actually about how to write this, the content of a paper. So I will, this is typically the main structure of an article. You have a title, you have an abstract, which is a summary, then you have a number of keywords and classification terms. Normally you have an introduction, a section or introduction, which basically you introduce the topic. We will talk about this in detail, how to structure an introduction. And sometimes you put another section on motivation. Why do we need to why this work is important and interesting? Then you typically I have added here 2, but typically it's not just section number 2, but you have a number of sections describing your approach. You may have an initial section with overview, where you introduce the concepts, and in the kind of papers that we do in software engineering, you typically have a section on architecture and tool support, and another section on evaluation. Then you have related work. That's normally you always have a related work section that can go either after describing your contributions or before, right after the introduction. You put it after the introduction when you want to motivate your approach, right? So you review a number of papers, a number of works, and you come to the conclusion that there is a gap. There is no one does this thing, or this thing can be improved, and then in that way, then related work can fit after the introduction. But I would say that most of the time related work goes at the end. And then you have another section on conclusions and feature work. That's customary also. Then you have references, where you put here the citations, the citations to other papers that you, the papers that you cite in the text of your paper. So let's go through each part of a paper. So the title. I think it's a bit silly to talk about titles, but a few tips. Should concisely convey what the paper is about. So I try to avoid long titles. So a long title, I mean, people will read the paper anyway, no? So avoid using very long titles. And it should be, if you submit to a conference where there is a competition for slots, try to have a title that is catchy, to call the attention of reviewers and readers. And sometimes you can also use a subtitle. So these are just a few examples of titles I have used. Recently, for example, Datalyzer, streaming data applications made easy. So it's a little bit like a commercial even, but it's a short title. Or refactoring multi-level models. And this one is interesting because it has a subtitle, facet-oriented modeling, that's the title. And then as a subtitle, open objects for model-driven engineering. Then authors, we have also mentioned about authors, about the positions, the importance of the positions. Pay attention to this. Typically, the first author is the one with most contributions, and typically the last one is the one, maybe the supervisor, typically in PhD papers. Sometimes you use alphabetical order, but if you use that, well, we have used alphabetical order ourselves whenever we have written papers in collaboration with other groups. That may be typical, but just indicate that you follow alphabetical order. Right. The abstract. The abstract is important because it's a summary of the main points of the paper. It should also be short, and in addition, in some conferences and some journals, you have a limit, a limit in words or in characters. And sometimes, some venues or some journals, they, for example, the Information and Software Technology Journal, they force you to follow what they are called structured abstracts. So basically, they're abstracts that they contain sections. They have a context, where you explain the context of the work, the objective of the work, the method that you have used, results that you have achieved, and conclusions. That's typically the sections of the structure abstract. I will put you an example here of a recent paper that we wrote on systematic mapping study. By the way, these structure abstracts are often found in empirical software engineering venues. So if you submit to the empirical software engineering journal, typically you will find this kind of abstract. So you see that in the abstract we have a structure with background, the use of chatbots, blah, 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 aim, which is the objectives. Our objective is to identify the state of the art in chatbot usability, blah, blah, blah. Method, how we have solved this, how we have achieved the objective, which is through a systematic mapping study. Results, we have categorized the work using 4 criteria, and conclusions, the conclusions of the paper. So you see that this is a way in which you convey all the information of the paper very condensed in the abstract. Right, then you will see that typically you have keywords, and normally you have 3 or more, and normally you order them from more general to more specific. For example, model-driven engineering, model transformations, APL, which is a particular transformation language. Why are they useful? Well, they help you to find your paper when you search for it, helps to assign reviewers, and helps the reader to understand what are the main topics of the paper. Also, you submit to ACN conferences. I think that the Lowcomote workshop will follow an ACN template. You should also provide this classification. So there is a standard classification system by the ACN, where you can select the topics of your paper using this hierarchy. For example, software and its engineering, software notation and tools, software description languages, UML. If you are happy with this topic, you assign this to the topics of your paper, and you say, okay, this is high relevance. And once you are finished with adding these topics, you can generate this classification, and then you include this in your paper. So that's very normal. Right. What else? The introduction. The introduction, I would say, that is probably the most important part of the paper. Why? Because it is first. I mean, it's silly, but it's it's the section where you introduce the problem, and the reader will decide whether to continue reading or not. Maybe even in the abstract, right? But you should here catch the attention of the reader, catch the attention of the reviewer. You have to introduce the problem, motivate the work, describe what is in the paper and the main contribution. And typically, it will follow a funnel shape. So it's broad at the start, introducing general background, general concepts, and then narrow at the end, where you will focus on the current paper. So typically here, as I said, you may even introduce some short background on the domain. Depends on the audience. For example, if you are going to write a paper for the models conference, it doesn't make much sense to put a lot of background on model-driven engineering and so on, because everyone will know about it. All the reviewers and the readers will probably know about it. Then you need to introduce the current situation, how the problem you are tackling is solved currently. What is the current situation? What was the problem that you want to solve, and why is it relevant? And then you need to describe the contribution. Once we know a little bit of background, we know the context, we know how this problem is attacked currently, how do you improve it? How do you improve with respect to the state of the art? And probably, possibly enumerate explicitly what are the paper contributions. If you are doing incremental work, because you have a previous paper that you have extended, you always have to explain what are the advances, deltas, with respect to your previous work. For example, if you would write a paper for a conference and then extend it to a journal, you need to explicitly state what did you add, what is novel in this paper. Because if you don't state it, the reviewers may reject your paper because they don't know what is novel of this paper with respect to your previous work. If you are writing a very short paper, maybe you embed here the related work, but that's for normal papers, that's not typical. And what is done almost 100% of the times is that you finish with a paragraph describing the organization of the rest of the paper. A paragraph that may be read like, the rest of this paper is organized as follows. Section 2, blah, 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 because you are in section 1, you don't need to explain section 1. Section 2 includes blah, 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 and so on. So what I will do is we will have a look at this paper here. This is a paper that we wrote very recently for IEEE PSE, where you see we have an abstract, we have index terms. This is IEEE, so we don't have this ACN classification. But then you see in the introduction, we start with a very broad paragraph explaining what is modeling, what are models, and so on. Why? Because this journal is not specifically for modeling. It is for software engineering. So it's good to introduce what is models, what are modeling languages, and a little bit the problematic here. The problem here is that we want to define variations of modeling languages, and we want to analyze those variations. So we put here a little bit in the context why these model variations are needed. For example, we cite this paper where they report many variations of architectural languages. So you see, we are preparing here the stage for explaining our contribution. So now we give more background because we introduce software product lines, which are a way to cope with variability. And now, this is sometimes you do this, we even present a motivating example even in the introduction. So we introduce an example where we want to build a meta model with variations to describe different types of petriness. And we describe here the example. And then we explain that without our techniques, this will be very different to very difficult to maintain because we will have many variations of this and so on. And then we finally here we introduce, okay, this paper makes this contribution, we explain the contributions and so on. And then we finish with these two paragraphs. Here we explicitly list what are the contributions of the paper, so the reviewers cannot be mistaken. So we make, we explain the deltas with the previous work. That's mandatory, and then we provide paper organization. So this is a very typical scheme, no? That you go from very general descriptions to describe a problem, and then you motivate how your techniques will solve this problem, and end either with contributions or with explanations on how you extend your previous work, and with the paper organization. This is very typical, and I would say most of the papers will have this paragraph at the end of the introduction. Questions so far? Right. Then after the introduction, there's the main part of the paper. Sometimes it's good to start with an overview where you describe usage scenarios or provide a general overview of the process that you describe or something like that. Then in software engineering papers, you will have typically architecture and tool support, and you will many times will have an evaluation, right? If you submit to a journal, you will need to validate your work. You will need to provide an evaluation where you show that it's better under some metrics than existing work. For the evaluation, you normally will formulate research questions. So is this tool more efficient than existing tools? That would be a research question. And then you need to design an experiment to answer this research question, right? You design the experiment, explain this design, you introduce the results of the experiment, and you always should include threats to validity. Things that may hamper the validity of the experiment that you have just described. We will see an example. So I will go back to this paper here.
Question?
Yes.
Do you think the overview section is like the background?
Yeah.
I've seen some papers where they call it background, I think.
Well, these are two things. One thing is background. For example, you can introduce background about some techniques, for example, model-driven engineering, product lines, or whatever. This is background that is needed to understand the paper. And it's also common to have a section at the beginning, maybe section 2 with background. But then the overview, what I meant, overview is an overview of if you are, for example, presenting a tool where you follow a methodology, you follow a process, you may just have a section overview where you describe the general parts of your solution. And then you will have additional sections where you explain each one of the steps of your solution. Did I answer your question?
Yes, thank you.
Okay. More questions? Okay. So it's important that at the beginning you design the skeleton of your paper, which sections and which order you will follow, right? That's very important. So for example, here we describe this is already a contribution. So product line, meta model, product lines. Well, at the beginning we use concepts that are existing, but then we introduce new definitions and new concepts, right? Then we have more sections where we explain more contributions and more contributions. So I just want to focus here on, here. So we have a section on tool support. So I have presented you a lot of stuff with algorithms, with proofs, with theorems. And then at some point I tell you, okay, we have implemented this using this tool, which is based on EMF, is based on Eclipse, and so on. Sometimes you even go and write and produce here an architectural diagram. You provide here some screenshots. Typically, normally we number the different parts of the screenshot so that you can easily refer to each part. Because otherwise you would need to say the window that is in the top right, and that's very cumbersome to use. So normally you say label 5 in the figure shows the wizard, blah, blah, blah. Then we have an evaluation where you will have, in this case, we only have one research question, which is the lifted property satisfiability analysis on the meta model product line faster than analyzing each meta model separately? So that's a thing I want to answer. And to answer this, I have to design an experiment, right? And in this case, we do 2 experiments in 2 situations. And then basically here we describe the results. And you see that we finish with threats to validity. What are threats to validity? Well, there is a lot of things to say about this, and this is about empirical software engineering. This is not the focus of this seminar, but these can be classified into different parts, internal, external, and so on. So these are factors that may make your results not fully general, or things that may hamper the result. For example, we have used, I think, these meta models, right? But these are only 8 meta models. So maybe if I repeat the experiment with more meta models, I will get different results. So that's a threat to this experiment. And don't be afraid, because each experiment has a threat to its validity. So you need to listen them here and try to argue on how you have tried to lower the effects of the threats. So,
excuse me, I have a question in this threat to validity. Is this the like critical analysis of the methodology that we will adopt?
Yeah, well, it's a critical analysis of the experiment.
Okay.
So you see that you reflect on how you have conducted the experiment, on the design and on the results, and you see, and you should hear, you should discuss why still the experiment is valid, but taking into account these threats. So I will show you here, yeah, this other paper. You see, it has a more extensive evaluation. It was published in Models last year, where we have 4 research questions, right? Where this is about the kind of testing, which is called mutation testing, where the goal is to evaluate how strong is an input test set for a program. And the way to evaluate this is by injecting errors in the program and see whether the test cases that you have can catch these errors. So we have a lot of research questions, and we even describe an evaluation setup for all the experiments. We provide here the results of the experiments, and then at the end we have, I would say, we have threats to validity as well, but a more extensive discussion. So this is typically the way you structure your experiments, by research questions, then experiments answering each research question, and then a discussion about threats to validity. And finally, I wanted to show you this another example where, coming to the question that we had before, we have a section on motivation and background, for example, after the introduction. This is a paper about synthesizing chatbots to query models. So instead of using OCL, we use natural language by conversation. So here, because we are using the concept of chatbots, we need to provide a little bit of background and also motivation. Why people would like to build to create queries using natural language instead of using OCL. So we use a motivation, and we use what is called a running example. A running example is an example that you will use throughout the paper to illustrate the different techniques. And it is very common. It's very common to have here a motivation where you introduce one usage scenario or more, but then present an example, a typical example, normally not very complex, so that you can use it in the rest of the sections. And then here we also provide a little bit of background. And then we describe the approach, but you see that we start with an overview of the process that we propose. So here we have integrated this in just one paragraph, but you may have one section dedicated to explaining how the process that you have designed will go. And you see that here in the examples that we provide, we use this running example here, so that we use just one single example for all the steps in our method. That's normally a good idea. If you are going to illustrate a tool or a method, present a running example and then use this example to organize the rest of the paper. Right. And as you see, well, this was for this is a short paper for a conference, but still we provide an implementation, a description of the implementation. And always we have related work. Okay, questions about this? Okay. Related work. Always.
Question.
Yes.
Juan, I have a question about the related work. Whenever you are describing in the related work about the research papers or in the background area, you should first tell about if you are referencing about some research paper or some citation, you should first tell about the latest one, or you can tell about whenever you are writing the paper and whenever in the context or in the sentence something comes, you just references. Or is there some hierarchy for this thing?
That's a good question. We will analyze how to structure the related work section right now. So I would like to answer if any of you have questions about introduction.
Yeah.
And main sections.
I have a question on, so can someone put related work in background?
Well, normally it's better to distinguish both. What is background? Background is something that you need to understand the paper. For example, I will put you an example here. We have this paper which is about mutation testing for ATL transformation, right? So we put here a background section. It's not called background, but it's called mutation testing. This just explains what is mutation testing. So this introduces what is testing, what is a mutation, what is the process of mutation testing. These are not related works. Related works come at the end, right? In this case, because you explain papers that focus on mutation testing improvements, and you compare these papers with your work. But background is initial concepts that you need to understand what the paper is about. More questions? Okay, so I would like also to come into Fatima's question about how to structure related work, right? Because sometimes you have a lot of related works, a lot of papers that are related to your research. How should you structure this section? Of course, you are not doing a systematic mapping study, so you don't have to go into super deep details about all possible papers, but you need to cover a really representative portion of the related work as much as possible. Right? And the thing is that if you miss a paper that does very similar things to what you do, and you don't consider it, that can be a reason to reject, because maybe a reviewer knows about that work, and then he doesn't know or she doesn't know how your approach improves that other work. So it's always important to consider the closest related work. And first rule is you should explain what is novel in your work with respect to these approaches. So you should really read those papers, read those related work, and understand what they do. If possible, try to use their tools to understand what is their approach and how you improve that related work. And what you normally do is you group the related work into groups of similar papers. So I will put you an example. Yeah, this one here. So you see, we are back in this paper about product lines of modeling languages. And in the related work, there are a lot of papers. So we decided to make groups. Sometimes you make subsections. Sometimes you just group the papers into paragraphs. Right? So for example, here we say, okay, works about model-based product lines. And then we analyze a few works here, but you see, we conclude that all these works apply software product lines to specific modeling languages. Instead, we work at the meta-model level. So here, we always have to say what is, how is different our work, or how our work improves these papers. And then we have variability in modeling languages, where we analyze a lot of works. And then at the end, we always have to for each paper, we need to say how our work improves those papers. And the same thing, analysis of model-based software product lines and so on. And at the end, I like always to finish with a few sentences doing a global analysis. For example, we know that analysis techniques for meta-model product lines are currently lacking. For this reason, we have done this and that. So, and we conclude, to the best of our knowledge, the lifting process using this and that is novel. Right? So we make a summary, what is the novel aspect of our work. So this really makes the reviewer know what is different, the reviewer and the reader. Questions on the related work? So related work section takes a lot of time, because you have to read a lot of papers, critically read them, and compare with your own work.
Okay, Juan, I have a question that when we are grouping the related work, we also in the group we also tell suppose some papers are from the 2019, so these papers should come first and the papers from the 2018 should come later.
Well, if that helps to understand your reasoning, that's fine. You can start from the oldest papers and then provide like a time overview of how this problem has been tackled a long time. Certainly, if you are analyzing different papers by the same authors, it's good that you start from the early papers. So generally, yes, that's a possibility. Within the group, you may start with the oldest papers first.
Okay, thank you.
More questions? And then sometimes you need to add appendices. What is this? These are sections that comes at the end, and that if you put them in the text, they would interrupt the reading of the reading flow. For example, if you work more in a theoretical computer science, you can introduce theorems, provide a proof sketch in the main text, but the details of the proof, you put them in the appendix. Or if you want to provide listings of related to your tool, you can put those lists. Of course, you will never put the source code of your tool. That's out of the question. But if you are, let's say, or if you have, for example, conduct an experiment with users where you have used a given form so that the users can reply to this form, maybe you can put this form as an appendix. And I would like to introduce you to show you this. This is a paper that we produced in collaboration with L'Aquila, and which is about the technique to reuse model transformation. This paper is a little bit theoretical, so you see we provide background and a running example. Again, that's very typical. We provide motivating scenarios, but then what basically we describe here is theory. Theory is in mathematics, and at some point we provide theorems. And these theorems, the proofs, we move them to the appendices. These are the appendix where we prove lemmas and theorems and so on. So that's very typical. If you have listings or whatever, you can put them in the appendix. And take care, because sometimes in the conferences, the page limit also includes the appendices. So you cannot put as many appendices as you like, but normally they count in the page limit. Right? Okay, so my tips here. Of course, I have a computer science degree. I don't have a literature review, but I have written many papers. So my recommendation here is follow an argumentation line. So approach writing a paper as you would approach writing an algorithm, especially the introduction. You want to convince the reader that what you do is useful as relevant. So write down the steps. So first I will introduce model-driven engineering, then I will introduce modeling languages, and I will finish saying that modeling languages need to have variability, but currently there are no techniques. So you see, it's a step-by-step process where you guide the reader through your thinking, right? So you have to make very compelling arguments and know where you want to head to and follow the reader step by step. And do not make large leaps in your reasoning, because maybe the reader will get lost. And if you say, there are currently no techniques to handle variability in modeling languages, you should provide a reference. So every claim that you make, for example, model-driven engineering improves productivity, you should give a reference, because otherwise, why should I believe you? You say that, but why should I believe what you say? Always document your claims with references. Another tip, don't use many words. This is not a novel. This is not a novel. So less is more, typically. Avoid long phrases. Avoid long paragraphs. Don't confuse the reader with long phrases. Go to the point. That's also important. And make clear what is the paper contribution, because sometimes I read the abstract and I say, okay, and so what is novel here? What is the contribution? Sometimes you can write it down in a list. These are the paper contributions. 1, I propose a novel method to describe variability in modeling languages. 2, I provide an analysis for this and that. Because otherwise I have read many papers that basically of this kind. I have built this tool. And so what? You have built the tool. And so what? In my spare time, I build many tools as well. Why should your tool be published? So you really need to make explicit the contributions. Also, you shouldn't start you shouldn't start working in a research field if you don't know what has been done in this research field. So you should really be familiar with related work and know exactly how is your work improving this related work. More importantly, it should be novel in the results, but who cares about the technique? I mean, if a problem is solved by using a technique, whatever, if I solve it using NDE, that's not a contribution because the problem was already solved. It is a contribution if my solution is better in some aspect, but the use of NDE to solve something that is already solved is not a contribution. And then in the paper itself, of course, you have to make proper use of images, diagrams, graphics, screenshots. So you have to explain well what you are talking about. Because maybe the reader doesn't have the background that you have. Of course, you are writing the paper. You know a lot about what you are writing about, but you need to explain it well and make the paper accessible to the readers. Okay, regarding the literature part, I would recommend you the Elements of Style. That is it's a very short book on writing in English, technically, and it's very. I mean, I'm not a native English speaker, and most of you are not either, and it gives you many hints for a proper writing style in English. So it started the first edition in 1920, but it has been re-edited because it's so good until a few years ago. You have also a few URLs here that you can have a look about writing tips. Questions about this? Right. So writing takes a long time. I mean, both writing a paper and writing good papers takes a lot of practice. But if you are not willing to write papers, if you don't like to write papers, it is a handicap, right? Because I mean, you need to communicate what you are doing. If you do something and this something is kept in your computer, this will not have an impact and will not benefit the community. Communicating what you are doing is the way for the community to grow and progress. Okay, so let's start with part number 3, which is about the technical part. How do I write a paper? First thing, sorry to disappoint you, or well, maybe you are not disappointed at all. No one uses Microsoft Word. Never use Microsoft Word. This doesn't give you a professional result for writing a paper. And personally, if I see a paper that is written in Word, I'm sorry, but I'm already biased as a bad sign of quality. And also more practically, it's difficult to do collaborative writing using Microsoft Word. Of course, you can use Google Docs, but if you use something more professional, like a version control system like GitHub, that's hell. I mean, that's impossible to have proper resolution of conflicts using Microsoft Word. So my advice is don't use Word for writing papers. I think 99% of researchers will use LaTeX. Are you familiar with LaTeX?
Yes.
Yes, we are.
Yeah.
That's good. I'm glad to hear that. Because is someone not familiar with LaTeX?
Yes, I'm not familiar with LaTeX.
Okay, that's normal. I mean, that would be the normal thing. What is LaTeX? LaTeX is, are you familiar with HTML or similar
Yes,
markup
of
language?
course.
Right.
Yes.
It's the same philosophy. So LaTeX is a markup language where you introduce marks to format the paper. Then you need to compile it. So you have a LaTeX source that you compile typically using PDF LaTeX. There are other ways to compile it using LaTeX that it will produce a DVI, and then you will compile it to PostScript, and then you compile the PostScript to PDF. But don't do that. There's no need to do that. Use directly PDF LaTeX. And yeah, I will go extremely quickly through this. And maybe the most interesting part here is the hints for how to structure a LaTeX project, right? So typically, in a LaTeX file, a LaTeX paper is written, is a plain text file. Normally, I use article.txt as the name of all my papers because I will use different folders, and I don't want to look because I may have different files. So I don't want to look what is the name of the entry point. So I always call them article.txt, or if you are more in the programming style, main.txt. And then you put here the content of your paper. So you see that these marks here are LaTeX commands. So document class informs the LaTeX compiler what is the type of paper you are writing. In this case, it's article, and here you give parameters. It's an A4 paper. It can also be letter, and then the size of the font, and then the paper goes between begin document and document. Right here, you write the paper, and you may have comments in using this percentage symbol. Then you compile, and then you get an article.pdf. That's the PDF that you could obtain with Hello World. So the purpose here of this seminar is not to teach you LaTeX from the beginning, just to give you some hints, because there are so many courses on LaTeX that you can check. Yeah, and LaTeX is also a super big language that I cannot really cover in a couple of hours. So, for example, I'm taking these very basic things from this course here, but there are many others. So, so everything that starts with this backslash is a LaTeX command, and the command may have parameters, and we have seen here. And you can declare your own commands, and that's a very good practice. So you can create macros, for example, for placing images in the file and so on. Okay, so this is what I have just explained about document class. That should be at the beginning, and you could also have begin and end document, and everything which is before begin is the preamble, where you can, for example, import packages with new commands, or you can define your macros. And one of the strong points of LaTeX is that the references, the citations, are handled automatically. We will see in a moment how this is done. And this is extremely useful for writing technical papers where you will have a lot of citations. So you can basically have a kind of database of citations that you can use in your paper. Okay, what else can you do? Well, there are predefined LaTeX commands like title, author, or date, for example. And then you have this command here, make title, that will produce this this part of the paper. What else can you do? Of course, you can add sections, and there is a command which is section that receives one parameter, which is the name of the section. And you don't need to care about labeling, about numbering the sections, because this is automatically done by LaTeX. The way to refer to other sections is by placing labels just after this section. You place a label, and this is the way you will refer to the number of this section. So you see that here we say we will finish in section, and I put here ref, which is the command to reference this label here. You have set conclusions, which is the label of this section. So automatically LaTeX will take care of this. So if I add new sections here, then everything will get recomputed. So I get something like this. Because labels may come after the reference, for example, here I'm referencing the section of conclusions, it's very common that you need to recompile several times the article so that the references are properly handled. Because if you don't do that, you will get here, instead of a 2, a question mark. If you see a question mark, either in the reference or in the citation, it means that you need to recompile again to resolve these references. And of course, during the compilation, you will the LaTeX will produce a PDF, but will also produce auxiliary files with this information for references, citations, and so on. Okay, then you have many other commands, for example, to add an abstract here, which you have with begin abstract and abstract, and you put here your abstract, and you see that at the end of the day, you can write a complete paper in this way. You have other commands like lists, enumerations, or itemize, depending whether they have every item has just a symbol here or has a number. Again, I don't want to give you a complete LaTeX course, but just to introduce you to LaTeX, and because that's probably what you will be using to write your papers. Of course, if you want to write a paper using LaTeX, you will not start like this. You will not start from scratch, but you will use the template of the conference or the template of the journal where you are submitting. And every conference, every journal may have a different style. What does it mean? You need to download the LaTeX style files and put them into your folder, or install it into your LaTeX repository. That's the other way. And then in the document class, you need to use that template. For example, LNCS is lecture notes in computer science. That's very common for conferences, and is the template file of Springer. Springer is is a very important publisher, and all the conferences that are published with Springer, they follow lecture notes. If you want to write a paper for an ACM journal or an ACM conference, you will use ACM art. And then you will configure with parameters the kind of conference or journals that you are writing to, because they will give you different styles. And also, depending on the template, you will get also some commands. To give you an idea, for example, that's the Springer template. That's how it would look like when you use the Springer template. Whenever you write a paper for sourcing, for example, you see it's double column. Whenever you write for ACM, for example, for the low-code workshop, you will need to use this template. You will see that it's also a double column. But for lecture notes, it's just one column. So when you see, okay, this conference is 10 pages long, the papers are 10 pages long, you also need to know what is the format, because a paper in 2 columns, you can put a lot more text than a paper in just 1 column. Right. Questions so far? Okay, so I think that one of the most interesting things about LaTeX is that you can basically handle the citations in a very nice way. So basically what you do is you have the citations data in a different file, which I normally call article.bib, because normally you will use bibtex, which is another utility to handle your references. And then within the paper, basically you need to put this command cite and then the paper name. And the paper name is one of the names that you use in this bibliographic file. Then to compile the bibliography, you need to use bibtext and then the name of the main article, and then it will produce an auxiliary BBL file. And then when you compile again with PDF LaTeX, you will take the information in this intermediately BBL file and put it into the main file. But the main file, I mean, the bibliography is an article.bib. BBL is just an auxiliary file. You have other options instead of bibtext, for example, Beaver, but I would not recommend it for a start. I mean, bibtext is very easy, is the most standard thing. Right, and then inside the article.bib, you will put the papers that you want to refer to. So you see every paper has a name, an identification, and then you have the metadata. So you have the authors, and each author is separated by this "and" keyword. You have the name and the surname. Then you have the title, then you have the book title, the pages, the year, the publisher, and so on. So there are a number of fields that are standard, and they depend on the type of the paper. So you see that this paper here is a conference paper because we have tagged as in proceedings. So this means that this paper is a conference paper, but you could also refer to journal articles, and then you put here article, and then you follow the same scheme, but you see that some fields are different. For example, here you need to put a journal name, right? You put journal, but here in the conference proceedings you don't put journal. And then volume, number, and so on. So yeah, there are many types of articles that you can put here, many types of publications. I would recommend you to have a look at bibtext.org to have a look at the format and the fields. And you don't need to worry about anything else, because with the command cite, you will get a proper citation, right? Depending on the template, you will get different styles for citation. Normally, citations, they have a number, paper 1, paper 2, paper 3, and so on. And then, depending on the journal or the conference, these papers will be ordered by the order of appearance, by alphabetical order, or whatever. You don't need to worry about that, because this is automatically handled by LaTeX and by the template that you are using. And also, depending on the template, you will get a number. You can get a citation like this, where you have the initials of the authors, or you have the name of the author, something like this. But this is done automatically. That's the good points of LaTeX. All this is handled automatically. Okay, I would like to finish this with a few tips. So I would, normally whenever I write a paper, I approach writing the paper as I would approach creating a programming project. So I create a folder, and I create a standard folder in my paper. So I have a figures folder where I put the images. I have a temp folder where I put auxiliary files. I have a related folder where I include papers in related work, and so on. Another, I think that's every research group. I'm pretty sure you have already worked with your supervisors. They have a different style for writing, a different approach to write papers in LaTeX. Just follow that approach. Another advice is break the paper into files. So don't put just one article.txt and you put the complete article there. But just as you could do with programming, with a program, break the file into break this into different files. Why? Because you will normally put these files under version control, right? And you split into different files, you will have less collisions and less requirements to resolve these conflicts. So normally what I do is I create one file per section, and then I include those files in article.txt. Yeah, then also Normally, it's better to use vector graphics for images whenever possible, so please avoid using BMPs and so on. Try to write a vector, try to obtain a vectorial image because it will scale much better. And also take care of images. Whenever I read a paper, of course you are young people and you use tablets and so on, but I don't. I print the paper. So when you print the paper, I don't have a color printer. So so if you use a color encoding for something, if colors are important, do something about that, because most people will, or many people will read your article printed, and then we'll see each color just as gray. Then create macros, just as you were doing a program. And yeah, we have talked about this. If you put screenshots, put labels in the different parts that you want to refer to. If you want to use listings, don't put an image. I have seen this many times. Just use a package where you that provides a command to introduce listings, which is LST listing, for example. And never submit without passing a spell check. Right, so in Word that's automatically done. In LaTeX, you can also use spell checkers. So please don't submit without checking the English carefully. Okay, in practice, what can you use to write? Because LaTeX is just the compiler, right? So you need an editor for that. One option, which I have been using for many years, is just use a basic editor, a plain editor like VI in LaTeX, or sorry, in Linux or something like that, and use the command line. So I always use the command line to compile my articles. I use a program which is called TextWorks, but I like to compile myself the article and produce the bibliography and so on, because sometimes you really don't know what is happening with these tools. For collaborative editing, because you will not write the paper by yourself, you need to collaborate with your supervisor or other colleagues, I would recommend you to use a control version system like GitHub. Don't use Dropbox. Well, you can use it, but come on, Dropbox is something that professional programmers never use. And a paper is at the end of the day, is very similar to a programming project. So I would say that GitHub or some other version control system is the best options, because you are writing text, and conflicts in text are very easy to handle, and allows you to work offline. If you travel and you are in an airport, you don't have Wi-Fi, you can still work on the paper. You don't need to be connected. Then when you have a Wi-Fi, you do a commit and resolve the possible conflicts. And because you know the rules of version control, of course, you need to put a single source of truth. So you put the text, article.txt, and the other sections and the images, but never you put under version control the auxiliary files that are produced during the compilation, like the BBL, the aux, the log, the article.pdf. So I get a lot of frustration with most of my PhD students, because they tend to put always this under version control. This is nonsense, because you only will get conflicts whenever you recompile, and you only get, I mean, it's a waste of time. Never do that. The other possibility is to use, instead of using a version control system like GitHub, is to use collaborative editing tool for LaTeX, like Overleaf. Overleaf is, have you heard about Overleaf?
Yes.
Yes.
Maybe some of you
Yes.
did. It's a tool that has a free version, where you go to overleaf.com, and then you have a cloud environment where you can create projects, and you can share this project with other people. And if different people are editing the same file, you will see the cursors here with their name. And then you see that here to the right, you can compile the PDF automatically in the cloud. Again, this is nice. I don't like it. I don't like it for two reasons. First of all, I need to be connected at all times, and secondly, there is not a clear understanding of what has been done by who. I mean, everyone can type here, so there is not a notion of commit. So, for example, I may be working in section 2, and I want to say I have improved section 2. Answering the review, the comments of reviewer number 2. That's my commit, and I want to commit this. And there is no this notion in overleaf. Of course, you can. There is a way to take this project in overleaf and to put it and to use a version control over it, but it's a little bit more complicated. And the free version doesn't have natively a very good version control system. But feel free to use whatever you like. Overleaf is very popular nowadays, I have to say. Especially, for example, for collaboration with other groups, that could be a good option, because otherwise you need to agree if you are going to use your local server for version control and so on. So Overleaf may be a good option for that. All right, so questions so far about LaTeX, about technical issues?
Yeah, I have one question.
Yes.
Regarding all the skeleton of the paper.
Yes.
What should we aim to write first? Because we are doing some methodology and some results. So if we have that part, so what should we aim to write it first? Can we write methodology first before introduction, something like that?
Well, it depends. So if you follow a programmer's approach, you would write the most important part of the paper first, the most critical one, no? Because that's, and so I would tend to write the main sections of the paper first, right? Because I think it's also a matter of organization, right? You typically will write this paper in collaboration with your supervisor or with other colleagues. So you are the one that has implemented the tool, has done the experiment. So it's good that you start writing the main body of the paper. And then your supervisor can focus more or can help you more with providing a good motivation, a good introduction, and so on. So typically, maybe your supervisor can write or can provide better motivation, a better introduction, or maybe he can provide you or she can provide you with hints on related work and so on. And so in my view, for you as a PhD student, it would be more helpful to start writing the main contribution of the paper first.
Okay.
And sometimes you really, the abstract you write at the end, no? Because then you have a clear idea of what you were able to put in the paper.
Yes. I have also one question similar to it. Like while reading the paper, should we follow the same method, like from abstract introduction? Because sometimes the introduction could be long and like sometimes it's boring. So what should we aim for? What should be the pattern of reading the paper?
Of reading?
Yeah.
Well, reading the paper, you do it from beginning to the end.
Beginning to the end? Okay.
Reading. I mean, you read the paper, that's sequential order is normal. Unless you are looking especially for example, if you are analyzing the related work, you have to read many papers. So sometimes you look the abstract, see, okay, this is the paper I was looking for. Maybe you skip the introduction and go to the main contribution to see how this paper relates to yours. But normally, I like to read the papers in full because I get the full context of the paper. And also, by reading other papers, you discover related work. That's also interesting. So if you skip the related work of other papers, you may not discover relevant work for you.
Okay. Yeah. Okay. Thank you.
More questions? All right, so let's start with the final part. Is okay, we have seen the context, the sections of the paper, how to write it in LaTeX, but let's see also the practical things about the process, right? So once you have your paper ready, you have selected the conference and so on, so you need to submit your paper for evaluation. And typically, this is done using dedicated web applications. The most used application is probably EasyChair, but there are others like HotCRP for conferences, and many journals have something called Manuscript Central, right? All these applications, they support the complete life cycle of the paper. Since the paper is submitted, then the editor assigns reviewers, the reviewers can upload reviews, then the editor can notify the authors can submit revisions and so on. So it covers the whole life cycle. And the idea of this seminar is also that you get used to this life cycle as well. So we will be using EasyChair to emulate a workshop, right? So you will need to register to EasyChair. You need to click here on login, or no, sorry, in Signal. If you don't have, maybe you already have an account. If you don't, then please, you will need to register, and then you can select the conference and submit a paper. So you see, that's what happens when you submit. You need to you need to fill in the title of your paper. If the conference has tracks, you need to select the tracks. You need to provide keywords. You need to provide an abstract, and then you need to submit the paper itself, right? So this is how you handle submissions in conferences. So I will, as I said, what we will be doing is we will be using EasyChair to emulate the conference. So you will need to submit your paper to EasyChair, but you will also need to review other papers. I think that's an interesting exercise because you will see what other people in this project is doing, and you will have the possibility to suggest improvements. So I will give you some tips for writing reviews. So what do you need to do? So you need to carefully read the paper that I will assign you and provide a score. Typically, the scores go from -3, which would be a strong reject, to a 3, which will be a strong accept. And in the middle, there is the 0. That means borderline. It can be either to accept or to the reject. You need to provide the confidence, typically from 0 to 5. 0 is I don't know anything about computer science, and 5 is I'm an expert on this topic. I have worked for many years in this topic, and I'm an expert. And then you need to produce a review text. In this text, normally you include a summary, a very short summary of the paper to provide the authors the impression that you have read the paper and you have understood the paper. Then sometimes you put a list of positive and negative points of the paper, the pros and the cons. And then you put the major concerns, things that you think are not properly explained, are not properly handled, and should be really improved accordingly. Then you also provide minor concerns, things that are not so major. For example, there is a figure that cannot be read because it's very small. If you find typos in the English, you should also list them here. But always, there is no need to be rude. Always use a positive tone. I mean, the goal as a reviewer is to help the authors to have a better paper. So always try to be positive, be constructive, and include suggestions for improvement. There is also, okay, so I want to put you here. So probably you should keep this confidential. That's a review I made a few weeks ago, just as an example. So here, first I start with a summary. This paper describes a Java library that has been used to develop a number of tools dealing with graph transformation or graph manipulation. Then my assessment, global assessment, the library looks useful in practice and could be of interest for the ICGT. It's a conference community. I recommend accepting this paper as a tool demo. In particular, this was a tool demo. And then I put here my main suggestions. For the library to be useful, it needs to be linked in some repository like GitHub. And more comments, the library itself is hardly explained and needs more details, blah, blah, blah. Then it's also very normal, if you know about related work, you can suggest this related work to the user. So I knew about these other works that were about also making library for graph tools. So I was suggesting these works for the authors, and it's useful because the authors now will take these papers, will read them, and will compare them in related work. And then I finish with details. For example, add references. Maybe you can include also here titles. There is also an ethics of reviewing, because you know, reviewing is normally anonymous. So please don't take advantage of being anonymous for being rude, or take advantage of this reviewing, anonymous review, for example, to recommend citations to your own papers. That's normally not a very good practice, but sometimes is the right thing to do if you see that your papers are really relevant for that other works. But don't just recommend your papers to get more citations. That's not really ethical. And also, no paper is perfect. I mean, every paper will have issues, will have problems, but focus on the positive parts of the paper, focus on the contributions and on the benefits to the community that the publication of this paper may entail. And also make a good, proper job. So you need to carefully read the paper and prepare a detailed review as the one you would like to receive for your own paper. So I think that's important. Okay, so that's what will happen next. So this seminar was just an introduction to writing papers, but the main point here is that this is going to be practical and you will write a paper yourself. So each of you is expected to write a paper on your research. And this paper will be used as a draft for the low-code workshop. So you don't submit now to the low-code workshop, but you submit to this local workshop that we are preparing, right? So you will write a paper, but then you will also review each other paper and then use these reviews to improve your own paper. And the goal is to learn the process, learn to write a paper, learn to write a review. Of course, here, if you get the paper accepted for a local workshop, it doesn't ensure that your paper will be accepted for the low-code workshop at Models, right? Because in the low-code workshop at Models, you will have other reviewers, right? So you will have professors reviewing your papers and so on. So there is a mistake here. So it should say low-code 20. This is low-code 20. And probably for the low-code workshop, you will receive the help from your supervisor. No? You will start from this draft paper and you will improve it with your supervisor to make it better and to address the comments that you have received in this local workshop. Okay, so what do you need to do? We will be using EasyChair. So you need to register to EasyChair to create an account if you haven't done it yet. And please do it during this week. Then you will need to write the paper, and the deadline for submitting the paper will be June 22nd at midnight. This will be a hard deadline. So if your paper is not there, you are not participating in the workshop, in this emulated workshop, and you are out. That's not nice. So please make every possible effort to submit your paper on time. Use LaTeX and use this template. So we will be using the template of this low-code workshop, which is ACM. So here we have the deadlines. And there is the possibility to submit, so we will be using ACM format. you can submit a 10-page long paper or a short paper. So talk to your supervisor and find the best option for you. You don't need to go to 10 pages if what you want to describe is still incipient. You don't have enough material for that. Okay, and where do you need to submit? So don't submit here because that's the real workshop in models. You need to submit here. This is the Lowcomote internal research work. Then click on make a new submission and then fill your details here, add the metadata, and finally submit the paper in PDF. Then, when you submit your papers, I will assign you 3 other papers to review, right? Because each paper will be reviewed by 3 reviewers. And then you need to submit the reviews by this, again, hard deadline, which is June 29th. Do your best to pay proper attention to the paper, read them, make interesting comments, try to help improving the paper. Again, there is no need to be harsh, to be rude, and so on. But of course, if the author didn't make a good job, you can add a proper suggestion, And the idea is, at the end, that you have an understanding of the process of a workshop or a conference, and to collect this feedback to improve the paper with your supervisor and finally submit it to the real workshop. And I think that that's all. I'm open now to questions if you have questions about anything we have covered or about the process of this internal workshop.
Hello?
Question.
Okay.
Yes, please.
Yeah, I have a question. So
yes.
if a paper is accepted on low-code workshop, is it going to be published as a workshop paper? Because I can see workshop papers on Google.
I didn't catch your last phrase. Sorry.
I'm wondering if the paper is accepted on low-code workshop, if it's going to be published, because I can see workshop papers on Google.
Yeah, it's going to be published. I mean, not in this local workshop, but in the workshop, in the low-code workshop affiliated to models, it will be published in the proceedings, and they will be published in the ACM digital library.
That's good.
Which is the library which is maintained by ACM. That's why you need to use the ACM format. Also use the ACM format for this pre-workshop, for this local workshop, because then it will be much easier to have the last version of your paper. And probably another question that you have not asked, but maybe you want to ask, is what will happen with the COVID restrictions to travel, right? You know that the low-code models is going to be in Montreal in October. So I'm talking now about the real workshop, right? But we may still have travel restrictions, right? And maybe we will not be able to attend physically the conference or the workshop. But in any case, models will take place, if not physically, it will take place virtually, which means that papers will be published in the proceedings, and presentations may need to be virtual, maybe creating a video or something like that. But many conferences right now in this period are being held either virtually or in a hybrid mode, where some people can go to the location. For example, if you live in Montreal, then I mean, why not going to the conference physically and present your paper physically, or if you live close to Montreal, but maybe you live in a country, for example, in Spain now, you cannot travel abroad, or if it is not for I mean, I think there are many restrictions now. But in any case, don't get worried, because the workshop and the models conference, they will take place, if not physically, virtually. More questions?
Hello?
Yes.
I have 2 questions. The first question is, I would like to get your comment on the impact of having figures in the paper, and how many figure like a concrete paper should have. Another question is about this low-code internal workshop, internal writing practice.
Yes.
If you are already working on a literature review paper, or you maybe finished that literature review paper. So are you going to write another paper, or am I going to rework on what I've already worked on if I haven't submitted yet? Yeah.
Okay. So regarding the figures, it depends. So the paper should have as many figures to convey what the paper is about. So I cannot give you a general answer. For example, my recommendation is, whenever you need to describe a process which has several steps, you can try to create a diagram showing this process, so that you can explain step by step what is this process. And then, yeah, for sure, try to include, well, I didn't do it here, but include, for example, if you are describing tools, include screenshots. If you are describing the architecture of your tool, include a class diagram. I mean, don't put too many figures as well, too many screenshots. Probably one screenshot is okay to get an understanding of your tool. And also, there is a limitation on the number of pages. So for example, here, this was a paper for models. So it means it's 10 pages long, exactly. And then the references. So if you put many images, you will miss this limit. So the second question is about what can you write about. So maybe you have already written a paper about a state of the art. The point is not to repeat that paper for this workshop, but to try to consult your supervisor to find, I mean, if you are working, I don't know, in repositories for low-code development platforms, let's say, try to describe that. So try to describe your working topic right now. You are, I mean, the technical topic, not, well, you can submit a literature review, that's fine. But you need to submit to this internal workshop what you would submit to the low-code workshop, which I think is probably more interesting to submit the main topic of your ESR, even if it is an initial stage. Why? Because you will get feedback about that. You will get feedback that will allow you to improve your work. So even if it is a little bit incipient or is in an early stage, you can write a short paper describing the architecture you envision and the motivation and so on. That's okay for workshop papers.
Okay, thank you.
Okay. More questions?
Excuse me, I don't have any question. If there is any other question, I would like to, if you agree and anyone else, I would like to take a screenshot of this virtual training to tweet on Lowcomote Twitter account. So if you agree, can you please show us the first page of the slides and the ESRs? If you agree, can you please turn on your camera so I can make a better screenshot?
Yes.
Yes, sure.
Okay. Here we are.
Okay, so the others don't want to turn on their camera. That's okay. So are you ready for taking a picture?
Am I the only one who cannot share his camera?
Okay, I think we cannot see anyone here, but I will do it. Thank you. So I'm finished. Thank you so much.
Thank you. Any other question? Okay, so if not,
me, just like one last question. This review what we're gonna do on this local workshop, it's gonna be double blinded.
Very good question. No, it's going to be single blind. Let's do things easier. So you need to put your name on the paper, and let's put only your name, not the supervisor name. Huh? Let's do it like this. Write the paper all by yourself. Put your name, and then for the models workshop, your supervisor will help and so on, and then you put their names as normal and so on. But for this, we are going to do single blind. It means you put your name, but then the reviewers will be anonymous. Of course, all the reviewers will be done among you. So please be kind in the reviews. Kind, but make every suggestion that you need to make. Did I answer the question?
Yes, thank you.
Okay, so yeah, I would ask you to register to EasyChair and start working on your paper using, of course, LaTeX. Download the template and use either Overleaf or whatever you want to use, and please submit by the deadline. Okay, so I think this video recording will be available so that you can enter again and see it. You may even be able to download it. I'm not sure. It's already 3 hours and a half, so it can it can be pretty large. Okay, so I'm glad to meet you. Have met you virtually, and I hope we will have the opportunity to meet again physically soon. Okay.
Yeah.
Take care.
Thank you very much.
Thank you. Bye.
Thank you. Bye.